A really quick screencast of the mutations worksheet answer. Here's your DNA right out here, and transcription would lead to the messenger RNA sequence, which is complementary to the DNA, except you have U's across from the A's instead of T's. You use the messenger RNA sequence every 3 letters, for instance, A, U, and G. That's one codon. And you come over here, A, U, and G, so A, U, G, and that's methionine, to be able to translate this messenger RNA into an amino acid sequence. So AUG, methionine. The next codon would be CGG. And come down here. CGG, arginine. And then you just put the abbreviations right here. If you want to know what the abbreviations are attached to your updates in your Schoology is this document called amino acid abbreviation, and there you have it right there, the names and their abbreviations. And so if you continue to translate it, you'll get methionine, arginine, serine, and proline. So the next one, you see that there is TAC-GCC is original and TAC-CCC. So this first G is substituted for a C, and so instead of coding for a C on the messenger RNA, it's going to code for a G. So let's read the original messenger RNA sequence: AUG-CGG for the first 6, and this is AUG-GGG. And so the second codon is what's affected. Instead of coding for arginine, it codes for glycine. But everything else is fine because there was a substitution. And so here's your new amino acid sequence. Now this third one, we have the deletion of this first C. So we delete it. See how there's 4 C's right here? Now there's only 3. That shifts everything to the left. And so what happens is you end up going from methionine, glycine, and serine to methionine, glycine, and histidine. And then we actually don't have enough to code for another one. So it changes the amino acid sequence that way. So we're going to call this a frame shift. And I put in parentheses specifically what type it was. It was the deletion. These are all chromosomal mutations. We went over them last unit, so you're not going to be tested on this unit, but just kind of as a refresher and review, there are 4 types of chromosomal mutations which involve big chunks of chromosomes or mini genes. And there's deletion, where you take a chunk of a chromosome and delete it. Insertion or duplication, where we add DNA. Inversion is where it kind of gets flipped around and reversed on the same chromosome. Translocation involves 2 chromosomes, where you take a piece of one chromosome and it gets displaced onto another. So the 3 types of point mutations, right? What can happen at one point is you can swap out one nucleotide for another. That's a substitution. Or you can add, which we call an insertion, or delete a nucleotide at one point. So all 3 of these are point mutations. The 4 chromosome mutations are the ones that you see up here: deletion, insertion or duplication, inversion, and translocation. So that's these right here. Now the only way that you can get a frame shift is either you add or insert a nucleotide into the DNA, or you delete one, and that's going to shift it to the left or right. Mutations involving 2 chromosomes, if you see here, is translocation, where one piece of one chromosome gets added to another piece of another chromosome. So that's a translocation. Can point mutations be frame shift? Yeah. So insertion and deletions, even though they're frame shifts, they happen at one point where you either insert a nucleotide at one point or delete one. So they're still considered point mutations. They're just a very specific category of point mutations. So we're matching all of these. This is the sequence F, A, C, D, H, B, E, G. So you can kind of see these are the definitions of all the different type of mutations. There's the answer. It's right there. A DNA segment is changed from this to that. What you'll notice, if you look very closely, AAG, AGG. So we substituted the A for a G actually, we didn't substitute, I'm sorry, we deleted this A, so it shifts it to the left. So if you actually count them, you'll notice that there's one less. So if you delete this A, everything shifts to the left, and it's like, just skip over this A, it'll go AGGACA, AGGACA. So you're just removing that A right there. Sorry. This one is a substitution because this last letter of the first codon, or the third nucleotide, we're substituting it from a T to a G. So the last 3 that are cat are still the same. So that's going to be a point mutation, specifically a substitution. So we take this DNA and then we transcribe it into RNA. So cross from T's or A's, cross from A's or U's, C's or G's, and G's or C's. And then every 3, so AUG, we're going to use this codon chart to figure out the amino acid sequence. And so AUG is methionine, GGG is glycine, and then CAG would be glutamine, so on and so forth. And then when you get to the UAG, you get the stop codon. What happens in the second one is we add a C right here, which is a frame shift mutation. And then everything before is the same, the insertion, right? Methionine, glutamine, glycine, and glutamine. But everything after is going to be affected because we've shifted the frame. So instead of tryptophan, codes for valine, and then alanine, and aspartamic acid, and then isoleucine. There's aspartic acid. I'll double check. ASP. Aspartic acid. And then, so that's a frame shift by inserting. This next one, we actually delete it, so we shift it to the left, so that's a frame shift by deletion, and you end up getting this. Remember, everything before, the methionine and the glycine, right, before is not affected. It's all the amino acids after the deletion or insertion, after the point mutation. And so this one right here, we're just swapping one out. We're just supplementing. If you say TAC, CAC instead of TAC, CCC. So this 1, 2, 3, 4, 5, this 5th nucleotide is substituted for an adenine. And so only that second amino acid is affected. So instead of right here where you see glycine, it's going to be valine. This is very much like sickle cell anemia, where we only affect one amino acid in the sequence.